welcome lecture session. Today's video I am going to explain the module 1 introduction and the Cauchy-Riemann equations, in short CR equations. Let's have the introduction. What is function of a complex variable? If z equals to x plus iy is a complex variable, then w equals to f of z is called a function of complex variable. It is u plus iv, where u is a function of xy and v is also a function of xy. Some of the important results which we note down. E power ix can be written as cos x plus I sin x, and e power minus ix can be written as cos x minus I sin x, and cos x can be written as e power ix plus e power minus ix divided by 2, and sin x is e power ix minus e power minus ix by 2i. And coming to conversion of imaginary the cos ix to cos hx, we have cos ix can be written as cos hx and sin ix can be written as I sin of hx. And also cos h ix is cos x, sin h ix is I sin x. And already you must be knowing the hyperbolic to exponential, that is cos hx is e power x plus e power minus x by 2, sin hx is e power x minus e power minus x by 2. And one more important theorem is the Demoris Theorem, which we are using it frequently, that is cos theta plus I sin theta power n is cos n theta plus I sin n theta for all values of n belongs to R. So when we have z as x plus iy is a complex number and x is r cos theta and y is r sin theta in the polar form, which implies z equals to r cos theta plus r sin theta into imaginary part, that is I r sin theta, which on simplification by taking the r outside, cos theta plus I sin theta, it will be r e power I theta, whose modulus is given by root of x square plus y square, and amplitude, that is theta, is given by tan inverse of y by x or argument. So x plus iy or r e power I theta, z can be written in this form, and f of z is u of x comma y plus iv of x comma y in the Cartesian form, whereas in the polar form it is u of r theta plus iv of r theta. Now let us have the introduction about what is limit of a complex valued function, continuity, differentiability and the analytic function. A complex valued function f of z defined in the neighborhood of a point. What is the neighborhood? Supposing if you are taking a point, say z0, the neighborhood is nothing but a small circle surrounded by this, and the points which are within that circle are all neighborhood points. Okay, so defined in the neighborhood of a point z0 is said to have a limit L as z tends to z0. So any point z which is tending to z0 will be very small. If for every epsilon greater than 0, however small, there exists a positive real number delta such that f of z minus L is less than epsilon when mod of z minus z0 is less than delta. This is written as limit f of z is L when z tends to z0. Coming to the continuity, a complex valued function f of z is said to be continuous at the point z0 if z tends to z0 and f of z0 exists. The limit f of z is equal to f of z0 when z tends to z0. That is, mod of f of z minus f of z0 is less than epsilon when z minus z0 mod is less than delta. Coming to the differentiability. A complex valued function f of z is said to be differentiable if f dash of z is f of z plus delta z minus f of z by delta z, when limit delta z tends to 0 exists and is unique. Next is analytic function. A complex valued function f of z is said to be analytic if its derivative f dash of z exists and is unique at the point z0 and its neighborhood of z0. So it is also called as holomorphic or a regular function. Next is the CR equations, in short, or Cauchy-Riemann equations in the Cartesian form. The statement says that the necessary conditions that the function w equals to f of z as u of xy plus iv of xy is analytic at any point z as x plus iy is that there exists four partial derivatives. The first order partial derivatives dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y, and also they satisfies the equation dou u by dou x is dou v by dou y and dou v by dou x is minus dou u by dou y. In short, we can also write it as ux is equal to vy and vx is equal to minus of uy. So let's see the proof of this. Let f of z be analytic at the point as z is equal to x plus iy, which implies f dash of z is limit delta z tends to 0 f of z plus delta z minus f of z divided by delta z exists. That is, the derivative exists. If z equals to x plus iy, then delta z will be delta x plus I delta y. Let us consider f of z as u of xy plus iv of xy. Then f of z plus delta z will be u of x plus delta x plus y plus delta y plus iv of x plus delta x plus y plus delta y. Now let us consider this part of the right hand side, that is f of z plus delta z minus f of z by delta z, which gives us u of x plus delta x, y plus delta y minus uxy divided by delta x plus I delta y. Similarly, for v also, I of v x plus delta x, y plus delta y minus v of xy by delta x plus I delta y. And we know thus the definition is this. Next, let us consider the two cases. Here the two cases will arise when delta z tends to 0, means we have delta x plus I delta y as 0. When delta x plus I delta y is 0, which part of it is 0? So let us consider the case 1 as delta y is 0, which implies that delta z is equal to delta x. That is, when delta z tends to 0 implies delta x also tends to 0. So the equation reduces to f dash of z is limit delta x tends to 0 u of x plus delta x comma y minus u of xy divided by delta x plus iv of x plus delta x comma y minus v of xy divided by delta x, which reduces to the equation 1 like this. That is, f dash of z is dou u by dou x plus I dou v by dou y. Let's call this as equation number 1. Let's consider the case 2 now. In the case 2, vice versa, that is delta x is 0, which implies delta z is I delta y. When delta z tends to 0, I delta y tends to 0. And since I is not equals to 0, therefore delta y is tending to 0. So our f dash of z becomes in the limit delta y. Here in this case, delta x was tending to 0, whereas in this case, delta y is tending to 0. Same result. But here, delta x was 0 and delta y is present here. Okay. So, what do we get as f dash of z? F dash of z will be minus of dou u by dou y plus dou v by dou x. Call this as equation number 2 now. Next, we will equate the equation 1 and 2. We get dou u by dou x plus I dou v by dou y and dou x is equal to dou I dou u by dou y minus of I dou u by dou y plus dou v by dou y. Let's equate the real and imaginary parts. We get dou u by dou x is equal to dou v by dou y. and dou v by dou x is minus dou u by dou y. Or we can also write it as ux is vy and vx is minus of uy. So let us see the CR equations in the polar form. If f of z is f of r e power I theta, which is u of r theta plus iv of r theta, is analytic at the point z, then there exist the four continuous first order partial derivatives ur, u theta, vr, v theta, and satisfies the equation ur is, or dou u by dou r is 1 by r into dou v by dou theta, and dou v by dou r is minus 1 by r into dou u by dou theta. Let's consider the proof of this. Let z is r e power I theta, which implies f of z is f of r e power I theta. So this implies u of r theta plus iv of r theta is f of r e power I theta. When we differentiate this with respect to r first, what do we get? Dou u by dou r plus I dou v by dou r is equal to f dash into r e power I theta into e power I theta. Because we are differentiating with respect to r, so this e power I theta will be treated as constant. So it is called this as equation number 1. Similarly, let us differentiate with respect to theta. We get dou u by dou theta plus I dou v by dou theta is f dash r e power I theta. There I r e power I theta will be multiplied. So now let us call this as equation number 2. Then we will replace 1 in 2. We get dou u by dou theta plus I dou v by dou theta is equal to IR into dou u by dou r plus I dou v by dou r. So equating, we will be getting dou u by dou theta plus I dou v by dou theta is IR dou u by dou r minus R dou v by dou r. If you equate the real and imaginary parts, what we are getting is the required CR equations, that is dou u by dou theta is minus R dou v by dou r and dou v by dou theta is R dou u by dou r. Rearranging, we get dou u by dou r is 1 by r into dou v by dou theta and dou v by dou r is minus 1 by r into dou u by dou theta. This we can also write it in the form of ur and vr as shown here. Thank you.